Let's use our comparison test to try to figure out if the following series converges or diverges. It's the sum from 1 to infinity of 1 over n squared plus 1. And it looks very like the sum of the p-series 1 over n squared, and as n tends to infinity, there really isn't much difference between 1 over n squared and 1 over n squared plus 1. So I suspect the sum of 1 over n squared is a good series to compare this to. Now, of course, before we use the comparison test, we should check that the terms are positive, but this is true. 1 over n squared plus 1 is positive for all n bigger than or equal to 1. Now, n squared plus 1 is bigger than n squared for n bigger than or equal to 1, and therefore 1 over n squared plus 1 is less than 1 over n squared for n bigger than 1, and this is good news because the sum of 1 over n squared is a p-series which converges. So in order to run our comparison test, we should be comparing a series to it whose terms are less than the terms of the sum of 1 over n squared. So we can now conclude by our comparison test that the sum of 1 over n squared plus 1 also converges because its terms are less than or equal to the corresponding terms of the sum of this convergent p-series.